Did you know that every breath you're taking right now contains atoms that were expelled by volcanoes billions of years ago? It's true. The oxygen entering your lungs at this very moment has passed through volcanic processes that helped form our atmosphere. Hello and welcome to another journey of discovery. Where are you right now? Perhaps relaxing at home or maybe walking while you listen? Regardless of location, I hope you're comfortable and ready for a unique experience. I'm your companion on this exploration, and together we'll unravel one of the greatest mysteries of our planet's creation. Before we properly begin our adventure, if you're enjoying the content, please consider subscribing to the channel and leaving a like on this video. It really helps me continue bringing this type of contemplative and educational content to you. And now, let's dive together into the depths of time. Close your eyes for a moment, if you wish, and imagine with me, what if I told you that nature's most destructive force is, paradoxically, also its most creative? Think about Earth billions of years ago. There were no continents as we know them, no crystalline blue oceans, no majestic snow-capped mountains. It was a young, violent, incandescent world. A planet in formation where fire and fury danced in a primordial symphony. And at the center of this cosmic dance, there was a force that few truly understand: volcanoes. Have you ever wondered why volcanoes exist? Why does Earth need to expel its innards in explosions of fire and molten rock? The answer is more beautiful and profound than we imagine. Volcanoes aren't simply manifestations of destruction. They are the secret architects of our world, the silent sculptors that, over eons, have shaped every continent, every ocean, every breath you take now. Imagine, for a moment, that you could time travel. Go back 4.5 billion years. Earth is a cosmic baby, still hot from birth. There's no life, no liquid water, just molten rock and toxic gases. And then, like a first breath, the first volcanoes begin to emerge. They're not pointed mountains like we see today, but gigantic fissures in Earth's crust, expelling magma in rivers of fire that extend for thousands of miles. These first volcanoes were the true creators of our world. Each eruption wasn't just an explosion of energy, it was an act of creation. The magma that sprang from the depths carried with it precious minerals, essential chemical elements, and most importantly, water vapor. Yes, dear listener, volcanoes were the first to give our planet the most fundamental ingredient of life: water. Can you imagine that epic moment? Millions of years of volcanic eruptions, each one releasing clouds of vapor that condensed in the young atmosphere, creating Earth's first torrential rains. Rains that lasted millennia, filling the depressions left by ancient eruptions, forming the first primitive oceans. But the story of volcanoes goes far beyond creating oceans. Each eruption also released gases, carbon dioxide, nitrogen, sulfur, that slowly began to form our atmosphere. Without volcanoes, there would be no air to breathe, no blue sky you see when you look up, no climate that allows life to flourish. And here lies one of nature's most beautiful ironies. Volcanoes, these apparently destructive forces, were actually Earth's first gardeners. Each eruption not only created new land, but also fertilized the soil with rich minerals, preparing the ground so that one distant day, the first forms of life could take root. Think about this as you breathe calmly. The oxygen entering your lungs, the soil beneath your feet, the water you drink, all of this has a direct connection to those first volcanic eruptions. We are all children of Earth's primordial fire. Have you ever stopped to observe a mountain? Really observe, contemplate its silent majesty, its curves sculpted by time, its imposing presence that challenges the heavens. If so, then you've already contemplated one of the oldest artworks of volcanoes. For, dear listener, almost all the mountains we know today began as volcanoes. Breathe deeply and imagine with me, millions of years ago, where Mount Fuji stands in Japan today, there was only a plain. But in Earth's depths, unimaginable forces were in motion. Magma, this molten rock that carries within it the planet's burning heart, began seeking a path to the surface. And when it finally found a weakness in Earth's crust, it exploded in an eruption that lasted decades. Layer upon layer of lava solidified, each eruption adding height and form to the nascent mountain. It's as if Earth were a patient sculptor, molding its creations not in days or years, but in millennia. Mount Fuji as we know it today, with its perfect conical shape, Its symmetrical slopes that have inspired poets and artists for centuries is the result of thousands of eruptions, each contributing to its unique beauty. But volcanoes weren't content to create only isolated mountains. In some places around the world, they worked together like a team of cosmic architects to raise entire mountain ranges. The Andes, for example, this rocky backbone that crosses all of South America, were born from the meeting of two tectonic plates, where volcanoes emerged like soldiers in formation, creating one of the planet's most dramatic landscapes. Have you ever wondered how it's possible for liquid stone to transform into solid mountains? It's a fascinating process, almost magical. When magma emerges from a volcano, it's at temperatures ranging from 1300 to 2200 degrees Fahrenheit. Imagine a river of molten rock, glowing like molten gold, flowing down the mountain like warm honey. But upon meeting the cold surface air, something extraordinary happens: transformation. The magma begins to cool, and as it cools, it crystallizes. Minerals reorganize, forming complex and beautiful structures. Some types of lava cool quickly, creating glassy rocks like obsidian, so sharp that ancient peoples used it to make blades. Others cool slowly, allowing large crystals to form, resulting in rocks like granite, with their unique patterns that look like abstract artworks. And it's not just mountains that volcanoes created. Think of islands, those precious jewels scattered across the world's oceans. Hawaii, Iceland, the Galapagos, the Philippines, all were born from volcanic fire. Imagine, somewhere on the ocean floor, thousands of meters deep, an underwater volcano began to grow. Eruption after eruption, it added height, fighting against water pressure, until finally breaking the sea's surface and creating new land. It's a process of indescribable beauty. First, just a few rocks emerge above the waves. Then, with more eruptions, a small island forms. Over time, the island grows, develops beaches, mountains, valleys. Ocean currents bring seeds from other lands. Birds arrive carrying life in their feathers, and gradually the island becomes a new world, a paradise born from fire. The Hawaiian archipelago is perhaps the most poetic example of this continuous creation. Even today on Hawaii's Big Island, Kilauea volcano continues its artwork, adding hundreds of acres of new land each year. It's as if we could watch world creation in real time, see Earth literally growing before our eyes. But volcanoes weren't just builders, they were also the planet's first engineers. They created not just forms, but also complex systems. Volcanic mountain ranges influence climate patterns, creating natural barriers that redirect winds and ocean currents. They determine where rain falls, where deserts form, where rivers are born. Did you know that some of the world's most fertile soils were born from the ashes of destruction? It's one of nature's most beautiful ironies. Where volcanoes once spread death and desolation, today life flourishes in its most exuberant form. Let me take you on a journey through the planet's greenest and most productive lands, where we'll discover that fire, paradoxically, is the father of abundance. Imagine for a moment the Tuscany region in Italy. You've probably seen its landscapes in movies or photographs: rolling hills covered with vineyards, golden fields of sunflowers swaying in the breeze, centuries-old olive trees nestled in verdant valleys. It's one of Europe's most prosperous agricultural regions, famous for its exquisite wines and premium olive oils. But would you know the secret behind this extraordinary fertility? The answer lies in the depths of time, when active volcanoes dominated this Italian landscape. Thousands of years ago, volcanic eruptions covered the region with thick layers of ash rich in minerals. These ashes, loaded with potassium, phosphorus, and an infinity of other essential nutrients, mixed with the soil over centuries, creating land of legendary fertility. And it's not just in Tuscany that we find this phenomenon. Java in Indonesia is another extraordinary example. Despite being located in one of the world's most volcanically active regions, or perhaps exactly because of it, Java manages to sustain one of the planet's highest population densities. Its volcanic soils are so fertile they allow multiple harvests throughout the year, feeding millions of people. But how exactly do volcanic ashes transform into this black gold of agriculture? It's a fascinating process that combines chemistry, biology, and time. When a volcano erupts, it doesn't just expel molten lava. An explosive eruption also releases extremely fine ash, microscopic particles of pulverized rock that can travel thousands of miles before settling. These ashes are like a concentrated mineral cocktail. They contain silicon, aluminum, iron, magnesium, calcium, potassium, basically all the elements plants need to grow strong and healthy. But there's more. Volcanic ashes also have a unique porous structure that allows excellent drainage, while retaining necessary moisture. It's as if nature created the perfect substrate for plant life. Breathe deeply and imagine with me. You're walking through a field of recently cooled lava. At first, the landscape seems desolate, just black, rough rock extending to the horizon. But if you look carefully, you'll begin to notice small green spots emerging from cracks in the rock. These are pioneer plants, the first life forms to colonize this apparently dead world. These pioneer plants are true heroes of nature. They can extract nutrients directly from volcanic rock, slowly breaking it down with their roots and natural acids. When they die, their organic remains mix with broken rock particles, creating the first centimeters of true soil. It's a slow process that can take decades or centuries, but this is how life reconquers the territories of fire. And then, gradually, other plants begin to arrive. Seeds brought by wind, by birds, by small mammals, find in this young, rich soil an ideal home. Within a few decades, where there was once only bare rock, an exuberant forest emerges. It's a miracle that repeats continuously around the world, in every place where volcanoes have left their mark. What's most fascinating is that different types of eruptions create different types of soils. Effusive eruptions, which produce slow lava flows, eventually break down into deep, well-drained soils ideal for crops like coffee and sugar cane. Explosive eruptions, which create ash layers, result in lighter, more aerated soils, perfect for vegetables and cereals. That's why some of the world's most famous coffee-producing regions, like the mountains of Guatemala, Colombia, and Ethiopia, are located in areas of intense volcanic activity. The coffee you might have drunk this morning could very well have grown in soil created by ancient volcanic eruptions. Have you ever stopped to think where the air you breathe comes from? Every inspiration you take now, every oxygen molecule entering your lungs and feeding your cells, has a story that goes back to Earth's first days. And at the center of this epic story, once again, we find volcanoes as fundamental protagonists. Breathe slowly and deeply. Feel the air entering, filling your lungs, bringing life to every cell in your body. Now imagine you could time travel, going back 4 billion years to Earth's first days. That young planet's atmosphere was radically different from what we know today. There was no free oxygen, no familiar blue sky, just a toxic mixture of methane, ammonia, hydrogen, and other gases that would be deadly to any life form we know. But then the great volcanic eruptions began, and with them, a slow but fundamental transformation of Earth's atmosphere. Each eruption was like a giant breath of the planet, expelling gases from Earth's interior to the surface. And they weren't just random gases. They were exactly the gases needed to create conditions that would one day allow life to flourish. The first and most important of these gases was water vapor. Imagine billions of tons of vapor being released by thousands of volcanoes scattered across the young planet. This vapor condensed in the atmosphere, forming immense clouds that covered the entire planet. And when these clouds finally discharged their load, the primordial rains began, rains that lasted millions of years, gradually filling Earth's crustal depressions and creating the first oceans. But volcanoes didn't contribute only water. They also released carbon dioxide in massive quantities. Today, we tend to think of CO2 as a climate villain. But in Earth's early days, it was fundamental for keeping the planet warm enough for water to remain liquid. Through the greenhouse effect, volcanic carbon dioxide created an atmosphere that protected young Earth from space's deadly cold. And there were more important gases being released: nitrogen, which would become our atmosphere's main component, sulfur, which would participate in complex chemical cycles, and a variety of other elements that would form the chemical foundation upon which life would eventually emerge. Have you ever wondered why Earth's atmosphere is so different from other planets? Mars, for example, has an extremely thin atmosphere, incapable of sustaining life as we know it. Venus, on the other hand, has an atmosphere so dense and toxic that surface pressure is equivalent to being almost a kilometer deep in the ocean. Earth found a perfect balance, and volcanoes were the conductors of this atmospheric symphony. But volcanoes' contribution to our atmosphere didn't stop in Earth's first billions of years. Even today, they continue to influence the composition of the air we breathe. Large volcanic eruptions can launch enormous quantities of particles and gases into the atmosphere that affect global climate for years. Do you remember Mount Pinatubo's eruption in the Philippines in 1991? It was one of the 20th century's most powerful eruptions, and its effects were felt worldwide. The volcano launched about 20 million tons of sulfur dioxide into the stratosphere, which combined with water vapor to form tiny droplets of sulfuric acid. These particles reflected sunlight back to space, causing a global average cooling of about 0.9 degrees Fahrenheit for the following 2 years. It's fascinating to think that a single volcano in the Philippines could affect the entire planet's climate. More colorful sunsets were seen worldwide due to volcanic particles in the atmosphere. It was as if the entire Earth had received a natural photographic filter, creating skies of extraordinary beauty. But not all volcanic effects on the atmosphere are temporary. Some eruptions in Earth's history were so massive they permanently changed atmospheric composition. The Deccan Traps in India are the result of volcanic eruptions that lasted about 30,000 years, releasing unimaginable quantities of gases into the atmosphere. Many scientists believe these eruptions, along with an asteroid impact, contributed to the dinosaurs' extinction 66 million years ago. It's a powerful reminder that while volcanoes are creators, they can also be dramatic transformers, capable of reshaping not just the physical landscape, but also the conditions that allow or prevent life from thriving. Close your eyes for a moment and imagine the ocean. Perhaps you visualize crystalline blue waves lapping a golden beach, or maybe the mysterious depths where fantastic creatures glide in perpetual silence. But did you know that the oceans you imagine, those vast bodies of water covering more than 70% of Earth's surface, owe their existence to volcanoes? It's an epic story that begins billions of years ago, when Earth was still young and turbulent. In that primordial time, there were no oceans as we know them today. The planet was a ball of molten rock, gradually cooling and forming a solid crust. And it was when the first volcanoes began to emerge that the magic really started. Breathe deeply and imagine with me thousands of volcanoes scattered across the young planet, each releasing enormous quantities of water vapor from Earth's depths. This vapor, carried to the atmosphere by violent eruptions, began condensing at high altitudes, forming immense clouds that covered the entire sky. And when these clouds finally discharged their precious cargo, Earth's most important deluge began. Torrential rains fell for millions of years, gradually filling every depression, every valley, every basin created by volcanic activity. The first puddles became lakes, lakes expanded into seas, and seas eventually united to form the first primitive oceans. But volcanoes weren't content just to provide water for the oceans. They also sculpted their shapes, created their depths, defined their boundaries. On modern ocean floors, we find one of the planet's most dramatic and geologically active landscapes, mid-ocean ridges. Have you heard of the Mid-Atlantic Ridge? It's a submerged mountain chain extending more than 6,000 miles along the Atlantic Ocean floor from north to south. It's like a giant scar in Earth's crust, where the seafloor literally separates and continuously renews itself. And do you know what's creating this impressive ridge? Underwater volcanoes. Imagine the scene, 2 or 3 miles below the ocean surface. Where pressure is crushing and darkness is absolute, volcanoes erupt continuously. But these eruptions are different from those we see on land. Here, hot magma meets the deep ocean's freezing water, creating a spectacle of steam and instant crystallization. The result is continuous creation of new oceanic crust. Each year, inches of new seafloor are created at mid-ocean ridges, slowly spreading to both sides like a geological conveyor belt. This is how oceans grow, how continents drift apart, how Earth's very face transforms over millions of years. And it's not just ridges that underwater volcanoes create. They also form seamounts, isolated mountains rising from the ocean floor like underwater cathedrals. Some of these mounts are so tall they come close to the surface, creating reefs and fishing banks rich in marine life. Others remain in the depths but serve as biodiversity oases in the apparent desert of the ocean floor. Have you ever wondered how volcanic islands form in the middle of the ocean? It's a fascinating process that combines volcanism and geological time. Imagine a hotspot in Earth's mantle, a column of extremely hot rock rising from the depths. When this column reaches the oceanic crust, it pierces it like a blowtorch, creating an underwater volcano. Eruption after eruption, this volcano grows, fighting against water pressure to reach the surface. When it finally emerges above the waves, a new island is born. But the story doesn't stop there. The tectonic plate continues moving over the hotspot, eventually carrying the island away from the magma source. A new island begins forming, while the old one gradually moves away and stops growing. This is how the Hawaiian Islands were born, a chain of volcanoes created by the Pacific Plate's movement over a fixed hotspot. Hawaii's Big Island, where active volcanoes still continue adding new land today, is the youngest in the chain. The other islands, progressively older as we move northwest, are like footprints left by the tectonic plate on its journey across the ocean. And underwater volcanoes don't just create islands and mountains, they also release complex chemistry into seawater. Hydrothermal vents, fissures in the ocean floor where hot water rich in minerals, gushes from the depths are like life oases in the abyssal depths. Around these vents, extraordinary creatures thrive, giant worms without digestive systems that depend on symbiotic bacteria, albino crabs, bizarre fish adapted to extreme conditions. Have you ever imagined what it would be like to witness the end of one world and the birth of another? Throughout Earth's history, there have been moments when volcanoes weren't just patient sculptors or silent gardeners, but rather forces of transformation so powerful they completely redefined the rules of life on the planet. These were the great creative catastrophes, volcanic events of such monumental scale. They ended entire geological eras and began completely new chapters in life's history. Breathe calmly and prepare for a journey through the greatest eruptions our planet has ever witnessed. Imagine, if you can, explosions so violent their echoes reverberated for millions of years, transforming not just landscapes but the very evolution of life on Earth. Let's begin with one of the most famous, the Toba eruption in Indonesia, about 74,000 years ago. This wasn't an ordinary eruption, it was a super eruption, an event so massive it almost extinguished humanity before it even began its civilizational journey. Imagine a volcano that expelled more than 670 cubic miles of material, enough to cover all of England with a 50-foot layer of volcanic ash. Toba's eruption was so powerful it launched so much material into the atmosphere that it blocked sunlight for years. Global temperatures plummeted between 5 to 9 degrees Fahrenheit, plunging Earth into a volcanic winter that lasted decades. Forests died, oceans cooled, and many species went extinct. Some scientists believe the human population at the time was reduced to just a few thousand individuals, our most direct ancestors, who survived this catastrophe and became the progenitors of all modern humanity. But if Toba almost extinguished our species, imagine what even larger events did in Earth's distant past. 252 million years ago, at the end of the Permian period, the greatest mass extinction in the planet's history occurred. Up to 96% of all marine species and 70% of terrestrial species disappeared. The culprit? A volcanic event of unimaginable proportions known as the Siberian Traps. For about 60,000 years, volcanoes in what is now Siberia continuously vomited lava and toxic gases. It wasn't a single explosive eruption, but rather an apocalyptic outpouring that covered an area of more than 770,000 square miles, larger than Mexico, with lava layers up to 2 miles thick. The released gases poisoned the oceans, acidified seawater, and created extreme global warming that transformed Earth into an almost uninhabitable world. Can you imagine the desolation? A planet where most life simply disappeared, where oceans became acidic and toxic, where scorching temperatures made vast regions uninhabitable. It was the end of one world, but also the beginning of another. For from the ashes of this catastrophe emerged a new era of life on Earth, with new groups of organisms occupying the ecological niches left empty by extinctions. And then, 66 million years ago, came another dramatic transformation. The asteroid that extinguished the dinosaurs is famous, but few know that almost simultaneously another massive volcanic catastrophe occurred, the Deccan Traps in India. For more than 30,000 years, this region vomited enough lava to cover half of the United States with a mile-thick layer. The combination of asteroid impact with extreme volcanism created apocalyptic conditions. Global forest fires, acid rain, nuclear winter followed by extreme warming. It was the end of the age of dinosaurs. But this catastrophe also paved the way for the age of mammals, allowing our distant ancestors to emerge from the shadows and eventually dominate the planet. Have you ever wondered if these volcanic catastrophes were really catastrophes, or if they were necessary transformations? Each of these great eruptions, however destructive it was at the moment, also created opportunities for new life forms to evolve and prosper. It's as if the planet had built-in renewal mechanisms, dramatic ways to reinvent itself, when life became too stagnant or when conditions needed to change. And these volcanic renewals didn't just affect life, they also reshaped entire continents. The lava flows from the Siberian and Deccan Traps created some of the world's most distinctive landscapes. The Deccan Plateau, for example, is one of India's main agricultural regions today. Its soils enriched by the ancient volcanic ashes that once brought destruction. It's fascinating to think that some of the world's most fertile and habitable regions today were created by history's greatest volcanic catastrophes. Iceland, land of geysers and active volcanoes, was born from one of history's largest basaltic eruptions. Today, it's a prosperous country with one of the world's highest qualities of life. Its homes heated by geothermal energy from the same volcanoes that created it. Have you ever noticed how weather seems to change mood without warning? How one day can be sunny and warm, and the next, heavy clouds bring rain and cold. Earth's climate is like a complex symphony with instruments playing at different rhythms, creating harmonies and dissonances that determine whether there will be abundance or scarcity, whether civilizations will flourish or decline. And among all the conductors of this climate orchestra, volcanoes are perhaps the most powerful and mysterious. Breathe deeply and imagine with me, you're in 1815, in what we now know as Indonesia, witnessing one of the most powerful eruptions in recorded history. Mount Tambora explodes with a force 100 times greater than Mount St. Helens, launching an ash column 27 miles high into the atmosphere. The explosion's sound is heard more than 1,200 miles away, and the darkness caused by ash lasts 3 days within a 375-mile radius. But the real effects of this eruption only began to be felt in the months and years that followed. Volcanic particles launched into the stratosphere created a thin veil around the entire planet, reflecting sunlight back to space and causing dramatic global cooling. 1816 became known as the year without a summer. In the middle of June, snow fell in New York, frosts killed crops in Europe, and monsoons failed in Asia, causing famines that killed millions of people. It's impressive to think that a single volcano in Indonesia could affect the entire world's climate, causing blizzards in the northern hemisphere's summer and famines in China. This eruption changed human history in ways we're still discovering. Lord Byron wrote his famous poem, Darkness, inspired by the dark skies. Mary Shelley, trapped indoors by the cold, stormy weather, created Frankenstein. And thousands of American families, their crops destroyed by abnormal cold, migrated west, accelerating U.S. territorial expansion. But have you ever wondered how exactly volcanoes manage to influence global climate? It's a fascinating process involving atmospheric chemistry, particle physics, and complex climate dynamics. When a volcano erupts explosively, it launches into the atmosphere not just ash, but also enormous quantities of gases, especially sulfur dioxide. This sulfur dioxide, upon reaching the stratosphere, combines with water vapor to form tiny droplets of sulfuric acid. These particles are so small they can remain suspended in the atmosphere for years, creating a translucent veil that reflects part of solar radiation back to space. It's as if Earth put on sunglasses, decreasing the amount of solar energy reaching the surface and causing global cooling. The effect can last years. Pinatubo's eruption in 1991 caused approximately a 0.9 degrees Fahrenheit decrease in global average temperature for 2 consecutive years. It might seem small, but in climate terms, it's a significant change that affects rainfall patterns, monsoon strength, and even hurricane frequency. But not all volcanic effects on climate involve cooling. Paradoxically, volcanoes can also cause global warming through carbon dioxide release. During periods of intense volcanism, like the massive basalt eruptions that created the Siberian or Deccan traps, massive quantities of CO2 were launched into the atmosphere, causing extreme warming that lasted millions of years. It's fascinating to observe how volcanoes function as the planet's natural thermostats. During periods of explosive volcanism, they cool the climate. During periods of massive effusive volcanism, they warm it. And throughout Earth's history, these volcanic climate variations have profoundly influenced life's evolution, mineral deposit formation, and even continental configuration. Did you know volcanoes also influence rainfall and wind patterns? Large volcanic mountain ranges act as physical barriers to air currents, creating different climate zones on opposite sides of mountains. The Andes, for example, block Pacific moisture, creating the Atacama Desert on the east side, one of Earth's driest places, while maintaining tropical forests on the west side, and there are still more subtle, but no less important effects. Volcanic ash launched into the atmosphere serves as condensation nuclei for cloud formation, influencing when and where rain falls. Volcanic eruptions can alter sunset color and intensity for years, creating visual spectacles of extraordinary beauty that have inspired artists and poets throughout history. The famous British painter J.M.W. Turner, known for his dramatic sky landscapes, painted some of his most impressive works during and after volcanic eruptions, when atmospheric particles created never-before-seen sunset colors. His canvases captured not just the beauty of these moments, but also volcanoes' power to transform even the sky's light. Have you ever held a diamond in your hand? Or admired the golden gleam of a gold nugget? Perhaps you used a smartphone today, without knowing that the rare metals in its circuits traveled thousands of miles from Earth's depths to your hands. Most of the mineral treasures we use daily, from the most precious jewelry to the metals essential for our modern technology, have a surprising origin. They were brought to the surface by volcanoes. Breathe calmly and imagine with me a journey to Earth's center. Thousands of miles beneath your feet, where pressure is crushing and temperatures reach thousands of degrees, Earth's mantle guards unimaginable treasures. Precious metals, rare crystals, elements essential for life all exist in the planet's inaccessible depths. But how do they reach us? The answer lies in volcanoes, those geological elevators that transport Earth's interior riches to the surface. When magma forms in the mantle's depths, it's not just molten rock. It's a complex solution loaded with dissolved minerals, precious metals, and rare elements that exist in low concentrations in Earth's crust, but are abundant in the mantle. As this magma ascends toward the surface, it undergoes a series of fascinating chemical transformations. Imagine magma as a rich mineral broth, boiling in the depths. As it rises and pressure decreases, different minerals begin crystallizing in specific sequences. The first to form are generally olivine and pyroxene, minerals rich in iron and magnesium. But as the magma continues cooling, rarer minerals begin to appear. This is how pegmatites are born, extraordinary rock bodies where giant crystals can form. In some pegmatites, we find quartz crystals the size of people, spodumene containing lithium essential for modern batteries, and green beryl that becomes precious emerald. These giant crystals can only form when magma cools very slowly, allowing atoms enough time to organize into perfect structures. Did you know that diamonds, those ultimate symbols of preciousness and beauty, also depend on volcanoes to reach us? Diamonds form at depths of 90 to 125 miles below the surface, where pressure is so intense it transforms common carbon into the hardest crystalline structure known in nature. But they would remain forever buried if not for special volcanic eruptions called kimberlites. These eruptions are different from anything else we know. They rise from the depths at incredible speeds, up to 125 miles per hour, carrying with them pieces of Earth's mantle, including precious diamonds. It's as if Earth occasionally decides to send samples of its most secret depths to the surface. And it's not just precious stones that volcanoes offer us. Many of the metals essential for our modern civilization are concentrated by volcanic processes. The copper that carries electricity in our homes, The gold that values our economies, the silver that makes photography and electronics possible, the zinc that protects other metals from corrosion. All these metals are frequently found in deposits created by volcanic activity. Breathe deeply and think about this process's complexity. When magma rich in metals contacts cooler crustal rocks, or when hot volcanic gases meet groundwater, complex chemical reactions occur. Metals that were dissolved in magma begin to precipitate, concentrating in veins and deposits that can be thousands of times richer than surrounding rock. California's famous gold deposits, which started the 1849 gold rush, were created exactly this way. Gold-laden ascending magma met cooler sedimentary rocks, and gold precipitated in quartz veins that serpentine through the Sierra Nevada mountains. Thousands of people risked their lives to extract this volcanic gold, and their discoveries changed the course of American history. But perhaps even more impressive are hydrothermal deposits created by underwater volcanoes. On ocean floors where seawater penetrates hot oceanic crust, it heats to temperatures of hundreds of degrees and dissolves metals from surrounding rocks. When this superheated water emerges again, loaded with dissolved minerals, it creates spectacular hydrothermal vents known as black smokers or white smokers. Around these vents, deposits rich in copper, zinc, lead, gold, and silver accumulate. Some of these deposits are so rich they contain more precious metals per cubic meter than many terrestrial mines. And they're being continuously formed, its mining being done by Earth itself in the ocean depths. And there are still the rare elements that have become essential for our modern technology. Lithium for electric car batteries, rare earths for wind turbine magnets, indium for touch screens. Many of these elements are concentrated by specific volcanic processes. Without volcanoes, our technological civilization simply wouldn't be possible. Have you ever wondered where life began? At what magical and mysterious moment did the first molecules organize themselves to create something that could reproduce, grow, evolve? This is one of the deepest questions we can ask, and the answer may lead us to a surprising place. Underwater volcanoes, in the dark depths of Earth's primitive oceans. Breathe calmly and imagine with me a journey 3.8 billion years into the past. Earth was a radically different place from the world we know today. There was no free oxygen in the atmosphere, no plants or animals, no complex life forms. The primitive oceans were hot, acidic, loaded with dissolved iron and other metals. It was a world that would be deadly to any life form we know today, and yet, it was in this apparently hostile environment that life began. And where, specifically, did this extraordinary transformation occur? Many scientists believe it was at volcanic hydrothermal vents on the ocean floor, oases of chemical energy in an otherwise cold and dead world. Imagine these vents, fissures in the oceanic crust where superheated water emerges from the depths, loaded with minerals and gases that would create perfect conditions for life's birth. These hydrothermal vents are like natural chemical laboratories. Hot, mineral-rich water creates gradients of temperature, pH, and chemical concentration that can catalyze complex reactions. It's here that simple molecules of carbon, hydrogen, oxygen, and nitrogen may have first combined to form life's basic organic compounds. Can you imagine the delicacy and complexity of this process? At the edges of hydrothermal vents, where hot water meets the ocean's cold water, porous mineral structures form small chambers and tunnels that could have functioned as the first cellular containers. Inside these natural microchambers, higher concentrations of organic molecules could accumulate, increasing the chances of chemical reactions that would eventually lead to the formation of the first living organisms. And the energy? Life needs energy to maintain itself, grow, and reproduce. At volcanic hydrothermal vents, this energy comes not from sunlight, which doesn't penetrate oceanic depths, but from chemical reactions. The process is called chemosynthesis. Organisms use energy released by reactions between chemical compounds to produce the complex molecules they need to survive. Even today, in the depths of modern oceans, we find entire ecosystems based on this volcanic chemistry. Around active hydrothermal vents, alien and fascinating life thrives. Bacteria that feed on sulfur compounds, giant tube worms that grow up to 6 feet long without digestive systems, albino crabs, bizarre fish adapted to extreme conditions. These modern deep-sea ecosystems may be windows into what life was like in Earth's first billions of years. Organisms that depend entirely on volcanic chemistry, that thrive in conditions that would be deadly to most surface life forms, that have found extraordinary ways to survive and prosper in absolute darkness. But volcanoes weren't just life's cradle, they were also its most rigorous teachers. Throughout Earth's history, volcanic eruptions created crises that forced life to adapt, evolve, find new ways to survive. Each great volcanic extinction eliminated species that couldn't adapt, but also opened ecological niches for new life forms to explore. It's a fascinating process of creative destruction. The Siberian traps, which caused the greatest extinction in history 252 million years ago, also created conditions that eventually allowed dinosaurs to emerge. The Deccan eruptions, which contributed to the end of the dinosaur era, paved the way for mammalian radiation. Have you ever thought that perhaps we owe our own existence to an ancient volcanic eruption? The ancestral primates that would give rise to the human lineage emerged in a world reshaped by volcanism. The volcanic landscapes of East Africa, with their rift valleys and alkaline lakes, created the savanna environments that forced our ancestors to descend from trees and eventually walk upright. And even today, volcanoes continue creating new habitats for life to explore. When an eruption creates a new island in the middle of the ocean, it becomes a natural evolution laboratory. Seeds arrive carried by wind or birds, spores float on ocean currents, and gradually a new ecological community establishes itself. The Galapagos Islands, which inspired Darwin to develop his theory of evolution, are all of volcanic origin. Each island, formed at different moments in geological history, harbors unique species that evolved in isolation. Darwin's famous finches, each species with beaks adapted to different types of food, exemplify how volcanoes not only create new land but also create opportunities for life to diversify and specialize. It's poetic to think that volcanoes, these apparently destructive forces, are actually life's great facilitators on Earth. They provided the chemical energy necessary for the first organism's emergence, created the diversity of environments that allowed life to diversify, and continued reshaping the planet in ways that constantly present new evolutionary challenges and opportunities. Have you ever held a volcanic rock in your hand? Perhaps a light, porous pumice stone or a polished piece of obsidian black as glass. If so, then you've held a time machine. For volcanic rocks are Earth's most precise timekeepers, storing in their crystalline structure the secrets of geological time and allowing us to reconstruct our planet's history with extraordinary precision. Breathe deeply and imagine with me the challenge that early geologists faced. How to determine the age of mountains that have stood majestically for millions of years? How to discover when a volcano last erupted, or how old the rocks beneath our feet are? For a long time, these questions seemed impossible to answer. But then we discovered that volcanoes, these fire artists, left in their creations perfect atomic clocks. When magma solidifies into volcanic rock, it captures and freezes in time the radioactive elements present at the moment of eruption. These elements immediately begin decaying into different isotopes at perfectly known and constant rates. It's as if each volcanic rock came with an internal chronometer, marking time since the moment of its formation. What's most fascinating is that different radioactive elements decay at different rates, giving us multiple clocks in each sample. Potassium-40 transforms into argon-40 with a half-life of 1.25 billion years, perfect for dating very ancient rocks. Carbon-14, with a half-life of only 5,730 years, is ideal for more recent events. It's like having a collection of chronometers, each specialized in measuring different timescales. Thanks to these volcanic chronometers, we could finally answer some of the most fundamental questions about our planet. We discovered that Earth is 4.54 billion years old. We established when the first complex life forms appeared. We dated the great mass extinctions. We reconstructed the history of moving continents. All this was possible because volcanoes, in their eruptions throughout history, left precise temporal markers scattered across the planet. But did you know that volcanoes also teach us about temporal rhythms much larger than human life? They reveal that Earth has its own cycles, pulses of activity extending over millions of years. periods of intense volcanism alternating with epochs of relative calm, as if the planet had its own breathing rhythms. Studying volcanic rocks in stratigraphic sequences, geologists discovered evidence of volcanic supercycles that repeat approximately every 27 million years. Some scientists speculate that these cycles might be related to the solar system's movement through the galaxy, or to variations in Earth's mantle activity. It's a dizzying perspective, our planet as part of cosmic rhythms that transcend our human experience. And it's not just rocks that preserve temporal records. Layers of volcanic ash preserved in oceanic and lacustrine sediments function like pages in a giant book of Earth's history. Each ash layer marks a specific moment in time, a volcanic event that can be correlated between different locations around the world. Imagine the precision of this dating system. A volcanic eruption that lasted only a few days or weeks can be detected in Antarctic ice samples, European lake sediments, and Pacific marine deposits. It's as if volcanoes sent dated postcards to the future, spreading them across the planet so that geologists millennia later could reconstruct exactly when specific events occurred. This temporal precision allowed us extraordinary discoveries. For example, we could determine that dinosaur extinction occurred exactly 43 million years ago, with a margin of error of only 11,000 years. For events that occurred so long ago, this is impressive precision, like determining the exact time of an event that happened when you were a child, but with a temporal scale millions of times larger. Volcanoes also taught us about the speed of geological changes. For a long time, we thought all geological processes were extremely slow, occurring gradually over millions of years. But studying volcanic eruptions revealed that some of Earth's most dramatic changes happened on surprisingly rapid time scales. The Deccan Traps, which contributed to dinosaur extinction, were formed in just 30,000 years, a blink of an eye in geological terms. And within this period, some of the most intense eruptions may have lasted only a few centuries or millennia. It's like discovering that events that fundamentally shaped life's history happened at the speed of human civilizations, not geological eras. Have you ever thought about how this temporal perspective affects our understanding of the present? We live in an epoch of relative volcanic calm, but rock records show us that periods of extreme volcanism are inevitable in Earth's history. It's just a matter of time. This understanding gives us both humility and urgency. Humility before the forces that shaped our planet, and urgency to understand and prepare for the changes that will certainly come. Can you hear it? If you stop for a moment and really listen, perhaps you can perceive Earth's almost imperceptible whispers. A slight tremor in the ground beneath your feet, the distant echo of movement in the depths, the silent pulse of magma circulating thousands of meters below. Volcanoes never really sleep. They just doze, and even in their deepest slumbers, they whisper clues about what's to come. Breathe calmly and imagine with me that you're a detective of the future, someone whose mission is to decipher the subtle signals that volcanoes send before awakening. It's a fascinating investigation that combines cutting-edge science, geological intuition, and a deep understanding of Earth's secret rhythms. For volcanoes, however unpredictable they may seem, actually follow detectable patterns if we know how to interpret their language. The first whispers usually come from below, in the form of small earthquakes that most people don't even feel. When magma begins moving in the depths, it fractures rocks, creates pressure, opens pathways. Each micro-fracture produces seismic waves that travel through Earth like ripples in a lake. Sensitive seismographs can detect these minuscule tremors, and specific patterns of seismic activity can indicate that a volcano is beginning to stir. But there are other more subtle signs. The ground around active volcanoes can deform slightly, rising a few inches here, sinking a few millimeters there as magma chambers fill or contract. Satellites equipped with radar interferometry can detect these minimal changes in topography, creating colorful maps that show how Earth's surface is silently breathing. And then there are the gases. Long before an eruption, volcanoes begin exhaling different cocktails of gases through fissures and fumaroles. Carbon dioxide, sulfur dioxide, hydrogen sulfide, each gas has its own chemical signature. And changes in proportions can indicate that new magma is ascending from the depths. It's as if we could smell a volcano's mood, detect its emotional changes through the gases it breathes. Have you ever imagined what it must be like to work as a volcanologist? Someone whose job is literally to listen to Earth's whispers? These brave scientists install equipment on active volcano flanks, climbing mountains that could erupt at any moment, collecting samples of toxic gases, measuring temperatures in steaming craters. It's a profession that requires not just scientific knowledge, but also physical courage and a deep passion for understanding the planet's most dramatic processes. And thanks to the work of these modern volcanologists, our ability to predict volcanic eruptions has improved dramatically in recent decades. We still can't determine exactly when a volcano will explode. Earth guards its secrets zealously, but we can often detect when a volcano is entering a state of growing agitation. This predictive capacity has saved thousands of lives. Mount Pinatubo's eruption in 1991 was preceded by weeks of warning signs that allowed the evacuation of more than 200,000 people from the danger area. Without these advance warnings, the eruption would have been one of the 20th century's most devastating humanitarian catastrophes. But predicting volcanoes isn't just about saving lives. It's also a window to understanding Earth's future itself. Volcanoes are expressions of deep processes that shape our planet long-term. Studying volcanic activity patterns, we can begin to understand how Earth evolves, how continents move, how climate might change in coming decades and centuries. And here we reach a fascinating realization. Although we live in an epoch of relative volcanic calm, geological records show that periods of extreme volcanism are inevitable in Earth's history. It's not a question of if, but when. At some point in the future, perhaps in centuries, perhaps in millennia, Earth will again experience periods of intense volcanic activity that will fundamentally reshape our civilization. Have you ever thought about how our species would face a super eruption like Toba or Yellowstone? How would our technological civilization, so dependent on interconnected global systems, react to years of volcanic winter? These are questions that don't have easy answers, but that modern scientists are beginning to investigate seriously. There's also the intriguing possibility that we might one day learn not just to predict eruptions, but perhaps even to influence them. Some speculative scientific proposals suggest that, in the distant future, we might be able to relieve pressure in volcanic calderas through controlled drilling, or even use geothermal energy from volcanoes as massive sources of clean energy. It's a fascinating vision, a humanity that not only coexists with volcanoes, but learns to work in partnership with these fundamental forces of Earth. Instead of just fearing them or fleeing from them, perhaps we can eventually understand them so deeply that we become collaborators in the planet's ongoing shaping. But perhaps the most important lesson volcanoes teach us about the future is a matter of temporal perspective. They remind us that Earth operates on timescales much larger than our human experience. While we measure our lives in decades, volcanoes measure theirs in millennia. While our civilizational history spans a few thousand years, Earth's volcanic history extends over billions. This perspective is simultaneously humbling and inspiring. Humbling because it reminds us how small and transitory we are in the grand scale of terrestrial existence. Inspiring because it connects us to something much larger than ourselves, to the deep, slow rhythms that shaped the world we inherited and that will continue shaping it long after we depart. It's fascinating to think that our modern technological civilization, which seems so advanced and permanent, still depends fundamentally on the same volcanic processes that shaped primitive Earth, the silicon in our computers. The metals in our cables, the elements in our batteries, all came from the depths through volcanic processes. We are a civilization built on the foundations of terrestrial fire. And perhaps this offers us a clue about how to navigate the uncertain future that awaits us. If we can learn to work in harmony with Earth's volcanic rhythms instead of trying to dominate or ignore them, perhaps we can build a more resilient and sustainable civilization. A civilization that, like volcanoes, combines creation and destruction, renewal and conservation in harmonious long-term cycles. Have you ever watched a metamorphosis? Perhaps you've observed a caterpillar transform into a butterfly, or followed the seasons changing a sterile winter landscape into an exuberant spring garden. Transformation is one of nature's most powerful and mysterious forces, and volcanoes are its supreme masters. They don't just create and destroy, they transform, cosmic alchemists that convert one type of reality into something completely different. Breathe deeply and imagine with me the extraordinary process of volcanic metamorphosis. When a volcanic eruption encounters existing rocks, it doesn't simply destroy them, it transforms them. Intense heat, extreme pressure, and chemical fluids loaded with minerals work together to fundamentally reshape rock structure, creating completely new materials with properties that didn't exist before. This is how some of the world's most beautiful stones are born. Marble, with its delicate veins and polished surface that seems to capture and reflect light from within, is common limestone transformed by volcanic heat. Slate, used in elegant roofing and sophisticated flooring, is humble clay metamorphosed by pressure and temperature. Gneiss, with its undulating patterns that look like waves frozen in stone, is granite restructured by extreme volcanic processes. But volcanic transformation goes far beyond simple rock alteration. Volcanoes transform entire landscapes, regional climates, complete ecosystems. A single eruption can convert a tropical forest into a lunar desert, but it can also, with time, transform sterile land into green paradise. It's a process of death and rebirth that operates in cycles transcending human experience. Do you know the story of Krakatoa Island? In 1883, a catastrophic eruption completely obliterated the island, creating one of the most powerful explosions in recorded history. The sound was heard 3,000 miles away. Tsunami waves circled the globe 7 times, and volcanic ash affected world climate for years. The island simply disappeared, leaving only a submerged caldera where there had once been land. But nature abhors a vacuum, and volcanic transformation doesn't stop at destruction. Gradually, underwater eruptions began building a new island in the same location. Anak Krakatau, child of Krakatoa, emerged from the waves in 1927 and has been growing continuously ever since. It's a powerful demonstration of how volcanoes aren't just agents of destruction, but also forces of continuous renewal. And as Anak Krakatau grew, life began to arrive. First, plant spores brought by wind, then seeds carried by birds. Insects arrived flying from nearby islands. Small mammals made the journey on floating logs. In less than a century, what was bare rock transformed into a complex and diversified ecosystem. Its evolution and colonization in accelerated time, a demonstration of how life adapts and thrives even in the most challenging environments. This transformative capacity of volcanoes operates on all imaginable scales. At the microscopic level, volcanic heat reorganizes mineral crystalline structure, creating new substances with unique properties. At the regional level, eruptions can alter river courses, create new lakes, modify climate patterns. At the global level, intense volcanism can change atmospheric composition and affect world temperatures for decades. But perhaps the most fascinating transformation that volcanoes promote is the transformation of our own understanding. Each eruption teaches us something new about the fundamental processes governing our planet. Each new volcanological discovery transforms our perspective on how Earth functions, how life evolves, how climate changes. Volcanoes transformed us from a species that saw Earth as static and immutable into one that understands our planet as a dynamic system in constant evolution. They taught us that mountains aren't eternal, that oceans aren't permanent, that even continents move and change over geological time. And this understanding in turn is transforming how we live and plan our future. We now know we must build our cities considering volcanic risks. We understand that our climate is influenced by deep geological processes. We recognize that geothermal energy from volcanoes can be a clean and renewable source of power for our civilization. Have you ever thought that perhaps we ourselves are products of volcanic transformation? Not just in the sense that volcanoes created the environment that allowed our evolution, but also in the sense that they fundamentally shaped how we think about our place in the universe. Volcanoes taught us humility before forces greater than us, but also inspired us with examples of constant creativity and renewal. Every time we contemplate a volcanic mountain, we're looking at a master of transformation. Every time we walk on fertile volcanic soil, we're stepping on evidence of the power to convert destruction into abundance. Every time we breathe air that has passed through atmospheric volcanic filters, We're participating in processes of purification and renewal that have operated for billions of years. Volcanoes teach us that transformation isn't something to be feared, but something to be understood and even celebrated. They show that even the most dramatic and apparently destructive changes can be necessary parts of larger cycles of renewal and growth. In their most violent eruptions, they also carry the seeds of new life, new landscape, new beginnings. It's a profound lesson about resilience and adaptation. Just as life finds ways to prosper in extreme volcanic environments, perhaps we can learn to find opportunities amid the most challenging transformations of our own lives. Volcanoes show us that even the most complete destructions can be preludes to even more magnificent creations. Can you feel it? If you close your eyes and really concentrate, perhaps you can perceive the subtle but constant movement beneath your feet. Earth is dancing a slow, majestic dance that began billions of years ago and will continue for billions more. And volcanoes are the most expressive dancers in this cosmic choreography, moving to rhythms that transcend our human temporal perception. Breathe calmly and imagine with me Earth viewed from space, not as a static photograph, but as a film in extremely slow motion, where each second represents millions of years. You would see continents gliding gracefully across the surface like gigantic stone rafts, oceans opening and closing like geological flowers, mountains growing and being eroded like waves of solid rock. And dotting all this majestic dance, volcanoes lighting and extinguishing like cosmic candles, marking the rhythm of planetary transformation. This is the dance of tectonic plates, and volcanoes are both its musicians and its dancers. Every plate movement, every continental collision, every oceanic opening is accompanied by volcanism. It's as if Earth uses volcanic eruptions to express the tensions and releases of its internal geological dance. At boundaries where plates separate, like in the middle of the Atlantic and Pacific Oceans, underwater volcanoes dance a slow waltz of creation. They spread new ocean floor like dancers extending their skirts, creating virgin terrain where there was once only water. It's a choreography of birth, where each step creates new territory and expands the ocean centimeter by centimeter, year after year. At boundaries where plates collide, volcanoes execute a more dramatic and violent dance. Here, where one plate plunges beneath another, friction and heat create perfect conditions for explosive volcanism. It's in these locations that we find some of the world's most active and dangerous volcanoes: the Pacific Ring of Fire, the Andes volcanoes, Japan's volcanic islands. Each eruption in these regions is like a dramatic note in the symphony of continental collision. And then there are hotspots, places where magma columns rise from the mantle depths like geysers of molten rock. These spots remain relatively fixed while tectonic plates dance over them, creating volcano chains like footprints left by a giant dancer. Hawaii is the most famous example, where the hotspot has created a line of islands as the Pacific Plate moves northwest. Have you ever stopped to think about the mathematical elegance of this dance? The velocities are perfectly coordinated. Plates typically move between 0.8 and 6 inches per year, approximately the speed of our fingernail growth. It seems slow to our human perception, but over millions of years, these movements completely remodel Earth's face. And the dance isn't limited to horizontal movements. There are also vertical rhythms, the slow pulse of Earth's mantle that creates undulations on the surface. Some regions gradually rise while others sink, creating elevation and subsidence patterns extending for thousands of miles. Volcanoes respond to these vertical movements, becoming more or less active as deep conditions change. It's fascinating to realize that this tectonic dance isn't chaotic or random. There are patterns, rhythms, repetitions suggesting a deep underlying order. Wilson cycles, the process of ocean opening and closing, repeat over hundreds of millions of years. Supercontinents form and fragment at regular intervals. It's as if Earth had favorite choreographies it likes to repeat, with variations throughout geological time. And we humans are privileged spectators of this eternal dance. Our species has existed for only a few million years, less than a second in Earth's geological music. But we've had the extraordinary fortune to develop the intelligence and technology necessary to understand and appreciate the majestic movements surrounding us. Through satellites, we can measure tectonic plate movement in real time. With global seismographs, we can listen to the vibrations of planetary dance. Using radiometric dating, we can reconstruct the steps of geological choreography over billions of years. It's as if we've developed the senses necessary to perceive a music that was always playing but was inaudible to us before. And this understanding is fundamentally changing how we see our place in the universe. We're not passive observers of a static planet, but active participants in a dynamic system in constant evolution. Our actions, especially regarding climate and natural resources, are part of the planetary dance. We are the first conscious dancers in Earth's history, capable of understanding and potentially influencing future steps in geological choreography. Volcanoes teach us that Earth's dance is simultaneously destructive and creative, chaotic and ordered, slow and dramatic. Each eruption is a movement in the eternal dance, a momentary expression of forces operating on timescales that challenge our understanding. And yet, through science and careful observation, we begin to perceive the patterns, feel the rhythm, appreciate the beauty of this cosmic choreography. While you breathe calmly wherever you are, remember that you're participating in this dance. The oxygen in your lungs was released by volcanic processes. The soil beneath your feet was created by ancient eruptions. The climate that allows your existence was shaped by volcanic gases. You are a child of Earth's eternal dance, a product of geological choreography that began billions of years before your birth and will continue billions of years after your departure. The dance continues, moment by moment, century after century. And now you know its steps, understand its music, appreciate its infinite beauty. Volcanoes are its eternal partners, guiding it through the cosmic rhythms that connect our small planet to the universe's greater rhythms. And here we arrive, dear listener, at the end of our extraordinary journey through the depths of time and Earth's igneous secrets. You've breathed with us through billions of years, witnessed the birth of oceans and continents, followed the eternal dance of tectonic plates, and discovered how volcanoes shaped not just our planet's physical landscape, but the very possibility of life. Breathe deeply once more and allow your mind to absorb the magnitude of what we've discovered together. Volcanoes, these forces that our initial intuition leads us to fear as agents of destruction, have revealed themselves as creation's true architects. They are Earth's heartbeats, pumping new life through arteries of molten rock that run through the planet's depths. Think about the poetic irony that permeated our entire exploration. Fire created water. Destruction generated abundance. Chaos gave rise to order. In every chapter of our journey, we discovered examples of this paradoxical truth, that nature's apparently most violent and destructive forces are, in reality, the most fundamentally creative. Volcanoes taught us that creation isn't a single event that happened in the distant past, but a continuous process that never stops. At this exact moment, while you listen to these words, new soil is being created in cooled lava fields. New islands are emerging on ocean floors. New minerals are crystallizing in deep magma chambers. Creation is a verb in the present continuous, not a noun in the past perfect. And perhaps this is the deepest lesson volcanoes have to offer us, that living means participating in a creative process that never ends. Every breath you take is possible because of volcanic processes that released oxygen into the atmosphere. Every step you take is on land created by ancient eruptions. Every heartbeat echoes Earth's deepest pulse, the igneous rhythm that has kept our planet alive and dynamic for billions of years. Do you remember how we began our journey? With a question about why volcanoes exist. Now, after diving into the depths of geological time and exploring the mysteries of planetary creation, we can reformulate that question in a deeper way. Why does Earth need volcanoes to live? The answer, as we discovered, is that volcanoes are the planet's circulatory system. They transport heat from the depths to the surface, recycle materials between Earth's interior and exterior, and maintain the chemical processes that make our world habitable. Without volcanoes, Earth would be a dead planet, cold, static, unable to sustain life. But there's still a deeper dimension to our understanding. Volcanoes connect us directly to the cosmos. The iron in our blood, the calcium in our bones, the carbon in our DNA, all these elements were forged in the nuclear furnaces of ancient stars and brought to us through volcanic processes. We are literally made of stardust refined by terrestrial fire. This cosmic perspective of volcanoes offers us a completely new way to understand our relationship with the universe. We're not accidental visitors on a hostile planet, but natural and inevitable products of the fundamental creative processes governing the cosmos. The same force that lights distant stars also feeds the volcanoes beneath our feet. We are children of universal fire. And this leads us to a final reflection about the future. Our species evolved during a period of relative volcanic calm, but geological records show us that this calm is temporary. At some point, perhaps in centuries, perhaps in millennia, Earth will again experience periods of extreme volcanism that will fundamentally reshape life conditions on the planet. How will we react when that moment comes? With fear and despair, or with understanding and adaptation? Our journey through Earth's volcanic secrets suggests the answer depends on the perspective we choose to adopt. If we see volcanoes only as destructive forces, we'll be paralyzed by terror. But if we understand their role as agents of renewal and transformation, we can find hope even in the greatest catastrophes. Volcanoes teach us that destruction and creation are two faces of the same cosmic coin. Every end is also a beginning. Every catastrophe carries within it the seeds of a new order. It's a lesson of resilience and renewal that transcends geology and touches the deepest dimensions of human experience. They show us that beauty and life often emerge from the most unlikely places, from destruction's ashes, from the scorching heat of the depths, from the apparent violence of eruptions. It's a powerful metaphor for our own lives, reminding us that even our most difficult moments can contain the seeds of extraordinary transformations. And perhaps this is the greatest gift volcanoes offer us, a new way to understand our role as conscious beings in a universe in constant transformation. Just as volcanoes are active agents in Earth's continuous creation, we are conscious agents in the continuous evolution of life and consciousness. Our capacity to understand volcanoes, to appreciate their destructive beauty, to find meaning in their cycles of renewal, is itself a form of creation. Through science, art, poetry, contemplation, we add layers of meaning to the physical universe. We are volcanoes of consciousness, eruptions of meaning in a cosmos that, through us, has begun to understand itself. Dear listener, our journey through Earth's volcanic mysteries comes to an end, but the story we explored together continues. At this very moment, magma is moving in the depths, preparing the next eruptions that will continue sculpting our planet's future. The eternal dance of creation and transformation continues, and we have the extraordinary privilege of being its conscious witnesses. Thank you for accompanying me on this exploration of the igneous forces that shaped our world. Thank you for your curiosity, your patience, your willingness to contemplate mysteries that transcend our everyday experience. Thank you for allowing us to discover together that behind volcanoes' apparent chaos and destruction, there's a deeper order, a more fundamental creativity, a more burning love for life than we ever imagined. And now, as you prepare to return to the everyday world, carry with you this transformative understanding. You are an integral part of the epic story we explored. Every atom in your body has passed through volcanic fire. Every breath you take is possible thanks to processes that began in young Earth's first eruptions. You are a continuation of cosmic creation, a conscious expression of the same creative force that lights stars and feeds volcanoes. And I leave you with a final question to contemplate in the quietudes of your reflective moments. What if Earth's apparent fury, expressed through its majestic and terrible volcanoes, is, in reality, the purest manifestation of its love for life, its tireless determination to continue creating, transforming, renewing the conditions that allow consciousness to emerge and contemplate the stars, that allows creatures like us to exist, to marvel at the beauty and mystery of the cosmos that gave us birth?